This is part 2, problems 11 through 18. These are multiple choice problems, and you are to, by the way, fill them out on the test itself. The questions are: classify each of the following as A, a pure substance, B, homogeneous mixture, or C, a heterogeneous mixture. And the first one is water that exhibits the Tyndall effect. And I'm qualifying that a little more by calling it 90-degree scattering. And that is the angle that the white light gets scattered. And so I should probably also qualify it as red light is scattered. This is an indication, because red light is scattered by a very shallow angle by water. That's why the sky, by the way, is red in the morning and red at night. It's a very shallow angle scattering of the light from the source, which is the sun. And the sky is blue in the daytime because it's a shorter wavelength of light, and it gets scattered to a much greater angle. When you see 90-degree scattering of red light in water, it's an indication that there are suspended particles in the water. And so that means it's a heterogeneous substance. It is suspended, not solvated. In other words, something like a solution, a homogeneous solution of sodium chloride will not give any greater scattering of light. But a suspended particles that are little tiny particles, nanoparticles that are just floating around within the water will scatter light at a much broader angle. And so that is one of the indicators that you have a heterogeneous mixture, not a homogeneous mixture. So this would be C. So the proper answer for this one is C. I'll put it over here. And number 12 is any metal alloy. Well, as solutions go, the most common example of a solution is the ones we were discussing, like in water or some sort of a liquid. But that's not the only type of solution that exists. There can be, like the air we're breathing, a gaseous solution of a mixture of nitrogen and oxygen, for that matter, is a homogeneous solution, a mixture. Metal alloy is a homogeneous mixture. It's uniformly distributed throughout. There's a mixture of more than one metal, and it is indeed an example of a homogeneous solution because it's uniformly distributed throughout. So this is a homogeneous mixture, or a homogeneous solution. Oh, I'm sorry, which is B, isn't it? Okay, so any metal alloy is a homogeneous mixture. Smoke. The aforementioned homogeneous mixture of air, when it contains smoke, if I were to shine my laser, which, let me get my laser. Here's my laser, okay? You cannot see the laser traveling through the air, okay? Now, that's because there is no scattering of light. There is no wide-angle scattering. Now, if I were to take for example, smoke a cigarette in the interest of science and demonstrate to you that you can see the path of the beam, and I were to blow it, I would take a puff of smoke and exhale, and it would go into the air, and you would see the beam traveling through it. I think you've all seen that. That is because smoke is an aerosol suspension of particles. It is not uniformly distributed. They are not dissolved They're not in the gaseous state. They're solid particles, and those scatter light. That actually is called the Tyndall effect. Go figure. Okay, so smoke is indeed C, a heterogeneous mixture. Now, 14, a pre-1970 copper penny, and I guess I should hyphenate that. A pre-1970 copper penny, and prior to 1970, pennies were made of pure copper, or as pure as they could get it. It may have been an alloy to a certain extent, but let's just consider it pure copper. And so this would be an example of a pure substance. Okay. A. Now, seawater, number 15. Seawater, if you've ever been out on the ocean, let's say when there was a beam of light coming through the clouds and you saw it hit the water, or if you take a flashlight and shine it into the water, you can see the beam traveling through the water. And the reason you can see that is because there is, again, a Tyndall effect. There are particles suspended in seawater that will scatter light. So this is another example of a heterogeneous mixture. So seawater would be a C for that. Okay, number 16. 1 ounce of gold. Well, it really, does the amount matter? No. It's an ounce of what? Gold. What is that? That would be a pure substance. So that would be A. Now, a partridge in a pear tree. Is that would that be a pure substance? Or perhaps a homogeneous mixture that is more than one thing but uniformly distributed throughout space? Or would it be a heterogeneous mixture? Obviously, it is C, a heterogeneous mixture. And now, last but certainly not least, is number 18, which is a large crystal of sodium chloride. And again, does the size of the crystal matter? Not a lick. This is, again, a pure substance. And that is 11 through 18.